Welcome to the lecture of data science. In this video lecture, we will cover the topic such as the association rule learning and the Bayes theorem. So this is one of the application of the simple probability rules. So let's get started. So starting with the first one, that is the application of the simple probability rules. In that we will see the association rule learning. So what is association rule learning? So association rule mining is one of the popular algorithm used to solve the problem such as the market basket analysis and the recommender systems. So the market basket analysis, in short, it is called as the MEA. It is used frequently by the retailers to predict the products that a customer is likely to buy together. Suppose there is one shopping market and one has analyzed from the data set that the chips and the cold drinks are both together and the bread is both together with the butter. So bread and butter are frequently bought together and the chips and the cold drinks are frequently bought together. The next example of the association rule learning is of the recommender system. So in this recommender system, the machine learning algorithm will work at the back end. So it will understand the audience and their preferences, and the machine learning also will understand the content of the asset, and accordingly it will match the asset and the person, and then it will display the recommendations. Suppose the one customer is interested to buy a book and the another customer is interested to buy a laptop. So accordingly, the recommendations will be shown according to the interest of the audience, and it will display the recommendations on your mobile app or the web pages. So the different famous organizations who are using the recommender systems are Netflix, Facebook, LinkedIn, Amazon, and so on. Now let's understand that what the association rule learning is. So in general, the association rule learning is a method of finding the association between the different entities in a database. So it will find out the relationship between the frequently purchased items. So the relationships will be in the form like this, that is the X implies Y. So suppose the chips and the cool drinks are frequently bought together, that we have identified from the database. Now let's see an example of the association rule learning, that this is my database which shows the binary representation of the point of the sale data. The rows shows the transaction ID, and these are the different fruits in my different columns. So one represent that that particular fruit or that particular item has bought. 0 represents that that particular item has not bought. So this is my first transaction ID. You can see that in my first transaction ID, my all the fruits are bought together except the strawberry. If you see the third transaction ID, then you can see that the green apple and the banana are bought together. So this is my complete data set, and I want to find out from this data set that which two fruits are bought together more frequently. So for that, the association rule learning will help me. So let's understand that how it will help you to find out the relationship between the two different items from the database. So for that, the three important measures of the association rule learning are the support, the confidence, and the lift. So what is the support? The support between the two set is calculated using the joint probability of the two events. What is the formula of the joint probability? That we have already seen in the previous video lecture. So support is the joint probability between the two events, that is my X intersection Y. The formula will be given like this, that is the number in the X intersection Y divided by the total observations. Next comes that is the confidence. So what is the confidence? It is the conditional probability of purchasing a product Y given that the product X is already purchased. So this event X is already occurred and I want to calculate the probability of the event Y. So the conditional probability formula is like this, which we have already studied in our previous video lectures. That is the probability of X intersection Y divided by the probability of the event that has already occurred. That is the P of X. Now let's understand the lift. So what is lift? It overcomes one of the disadvantage of using the confidence. So just for an example, if the value of probability of X is very small, then it will make the confidence very high. So it will make less attractive for the market basket analysis and for the recommendation systems. So in the lift, we have added probability of Y in the denominator. So this is the formula of the lift. Now let's understand this in our data set. So from this data set, I am taking the apple and the banana, only these two columns just for now. So taking the apple and the banana together and keeping this complete table, that is the transaction ID apple and the banana, in one place. Now let's calculate the support, confidence and lift for this particular data set. Assuming that X equals to apple and Y is my banana, then support will be, just put the values into the formula of the support, that is probability of X intersection Y. So let's see that what is the value of the X intersection Y, that is the apple and the banana. Then you can see that apple has bought, banana has bought. So these two items are bought together. So let's count the value of X intersection Y as 1. The apple has not bought and banana has bought. So this is my not the value of X intersection Y. So X intersection Y means this both the items are bought together. So how many ones are there, that the one in the X and the one in the Y? So this is my count as 1 and you can see that this is my count as 2. That is, these two items are bought together again. So the number of X intersection Y is 2 divided by the total observations are 7. So I got the value of support as 0.285. Now let's calculate the confidence. So this is my formula of the confidence and just put the values. So the probability of X intersection Y we got as 2 divided by 5 divided by the probability of X. So what is the probability of X? You can count how many ones are there. So out of the 7 transaction ID, the apple has bought 3 times. So the probability of X will be 3 divided by 7. So this is in the denominator. So I am writing 3 in the denominator and the denominator of the denominator will become your numerator. So 7 will be in the numerator. So I will get the last answer as 0.667 as my value of the confidence. Now let's calculate the lift. Just put the values into this formula of the lift, that is 2 by 7, 3 by 7 and 6 by 7. The probability of Y you can calculate from this banana column. Over here, how many total counts of 1 are there? There are 6 out of 7. So my probability of Y will be 6 divided by 7 and I got the value of lift as 0.778. So this is how you can calculate the support, confidence and the lift value for the different combinations of the fruit from your database. So over here, I have taken apple and the banana. You can take apple and the green apple in the combination. Just calculate the support, confidence and lift for all different combinations. So whose support and the confidence values are higher, you can say that two items are frequently bought together. So you can also make the threshold value. Suppose my threshold value of the support is 0.3 and suppose my threshold value of the confidence is 0.5. Then whose support and confidence value are above the threshold. So I can say that two particular items are frequently bought together. So this is how the association rule learning is helping you to find out that which two items are frequently bought together from your complete shopping mall. Now let's understand the next topic, that is the Bayes theorem. So the Bayes theorem is one of the important concepts in the analytics since several problems are solved using the Bayes theorem. So consider the two events A and B. So we can write the following two conditional probabilities. That is my probability of A that the event B has already occurred. So this is my formula, that is A intersection B divided by probability of B, that is the event has already occurred will be in the denominator. And my probability of B that my event A has already occurred. So A intersection B, that is the probability of A intersection B divided by the probability of the event that has already occurred. So using these two equations, we can show that instead of this particular A intersection B, I am replacing this value of A intersection B by this formula, that is probability of A pipe B into probability of B. So putting this value in equation 2, I will get the final equation like this. So this is what my final equation of the Bayes theorem is. Now let's start with solving the Monty Hall problem using the Bayes theorem. So first of all, we have to understand that what the Monty Hall problem is. So just remember that in the Monty Hall problem, it is one type of game show which contains one host whose name is Monty, one player. Suppose over here we will assume that you are the player. So there is one player, one host and three different doors. Out of these three different doors, one door will contain a car and two other doors will contain the goat. So let's understand this problem properly. Suppose in a game show, there are three different doors like this and this is the host of the game show. So over here in this game, the one door contains a car and two other doors will contain the goats, that is the baby goats. So over here, suppose you are the player and you do not know that which door contains the car and which door contains the goat. So over here, the host will ask you that to pick any of the door out of these three doors. So suppose the player, that is you are picking up the door as one. So before opening this door, what will happen? The host will open any of the remaining two doors. So you have selected this particular door as one, that is the door one. Now you want to win a car, but the car is behind only one of the door out of these three doors. Now you have selected this door. Now what the host will do? The host will open any of the door out of the remaining two doors. So the host knows that where the car is. So the host will always opens a door which contains a goat. So suppose the host has opened the door number 2. Now what will happen? Now the host will ask you whether you want to again change your choice out of these two closed doors, that is you want to swap your choice, or you want to stick with your initial choice, that is the door as one. So the player wants to win the car and the car is only behind any one of the door. So previously, what was the probability of winning a car out of the three doors when all the three doors were closed? Previously, the probability was 1 divided by 3. After the host has opened one of the door, now the probability of winning the car is 1 divided by 2. That is, the car is behind only one door, that is 1 in the numerator, divided by total number of observations. So there are two different choices available. So after the host has opened one of the door, now the probability of winning the car is 1 by 2. So like this, the player wants to win a car, so whether the player should swap his choice to win a car or whether the player has to stick with his initial choice. So you can solve the problem of the player using the Bayesian theorem. So let's understand that over here, let C1, C2 and C3 be the events that the car is behind the door 1, 2 and 3 respectively. And the D1, D2 and D3 be the events that the host, that means the Monty, opens the door 1, 2 and 3 respectively. Now based on this, we are solving the problem. So let's probability of C1, C2 and C3, that is the probability of that the event that the car is behind the door 1, 2 and 3. So initially it will be 1 divided by 3. That is, out of the 3 doors, only one door will contain a car. Now assume that the player has chosen the door 1 and the Monty opens the door 2 to reveal a god. So over here, we want to find out the posterior probability that the door 2 has already opened. That means the D2 event has already occurred. And I want to know that what is the probability that the car is behind the door 1. So what is C1? So C1 is the probability that the car is behind the door 1. So as the player has chosen the door 1, so I want to find out the probability of C1, that is the probability of car behind the door 1. Given that the D2 event has already occurred, so this is my Bayesian formula. So you can write this formula based on the generalized formula and you just put up the values. So you will get the answer as 1 by 3. So over here, you can say that probability of D2, that the Monty will open the door 2. So when the Monty, it means when the host will open the door 2, the host will open the door to after the selection of the player. So with the host, there are only 2 different choices and out of the 2 different doors, he will select only one door. So the probability of D2 is 1 by 2. Over here, the probability of C1, the initial probability is 1 by 3. And over here, the probability of D2, that the C1 event has already occurred. It means the host will open the door to, given that the C1 has already chosen by the player. So again, its probability will be equals to 1 by 2. So your final result will be 1 by 3. So let's see now over here that probability of D2 pipe C1, that is 1 by 2. It means if the car is behind the door 1, then the Monty opens either the door 2 or door 3. Now let's just take an example that over here that the player is changing its initial choice. So what is the probability that the car is behind the door 3 given that the door 2 has already opened? So just put the formula and you got the answer as 2 by 3. So of course this value that the car is behind the door 3, the probability of winning that particular car, if you change the choice, then it is 2 divided by 3. If you stick to its previous choice, if you stick to its original choice, then the probability of winning the car is 1 by 3. If the player is changing its initial choice, then the probability of winning the car will increase. So this is how the Bayesian theorem has helped the player to win the car. So this is what the solution of the Monty Hall problem is using the Bayesian theorem. Let's understand now the topic, that is the generalization of the Bayes theorem. So over here it is my event generated from the mutually exclusive subsets. For better understanding, suppose consider a part manufactured by the suppliers. These are the suppliers, that is B1, B2 up to Bn. And let A denote a defective part. So all the suppliers are supplying some sort of defective parts to the organization. Now I want to find out that what is the total probability of receiving a defective part. So you can find out the total probability of A like this, that is probability of A comma B1. So what is this A comma B1? It means the probability of A intersection B1. That is this part. That is the probability of A intersection B2. Probability of A intersection, this is B1. This is the probability of A intersection B2. Like this, I have the probability of A intersection Bn. So there are different suppliers and I want to calculate all the total probability of the defective parts. So I have to add up all the probabilities of the defective parts from all the different suppliers. So I am writing like this, that is probability of A comma B1, which is the probability of A intersection B1 plus the probability of A intersection B2 up till the probability of A intersection Bn. Now I can replace the probability of A intersection B1 with this formula. So what is this formula? Where this formula came from? So when you see the Bayes theorem, then you have the formula like this. That is the probability of event A given that the event B has already occurred. So from this particular formula, make the probability of A intersection B as the subject. So you will get probability of A pipe B into probability of B. So just imagine over here that probability of A intersection B1. So you will get the answer as probability of A pipe B1 into probability of B1 by using this formula. So you can add up all these probabilities and you will get the final probability of your defective part A. So from this video, you can able to answer all these questions, that is working of association rule learning, the Bayes theorem, solving the Monty Hall problem using the Bayes theorem and the generalization of the Bayes theorem. Thank you for watching.